Okay, this is the M2.5 by 10 millimeter screws, countersunk. With these kind of screws, you always measure from the top of the head. So this screw goes in the location here in the battery case, as well as the screw goes here on the encoder brackets. This is the M2.5 by 12 millimeter coarse screw, and these screws are always measured. It's called a panhead, and it's measured from the bottom of the head. These ones are long enough to go through the beagle board. In this case, they go through the spacer, through the beagle board, and into the plastic standoff that's designed into the bracket. The M2.5 by 6 panheads, they belong over here. One of them goes on the lid of the beagle board, which is not present right now, and then the other two go here in the driver. I'm going to remove one to show you how the driver is mounted. In this case, there's 4 holes in the circuit board, but we're only using 2 of them. And underneath the board, we have the brass heat set insert. And then this insert is an M2.5 female insert. It's found over here. The depth is 3.4 millimeters. This screw here is M2 coarse threads for threading into plastic, and it's used in 3 locations on the robot. The first location is in the encoder bracket. It holds the encoder circuit board using 2 screws per encoder. And you can see here, this is the encoder circuit board and this is the bracket. So the right hand side uses 2 that are catty corner. The left hand uses the alternate 2 that are catty corner. And then the other location for these screws, if necessary, it's going to go into the ultrasonic sensor in these 4 holes. This M60 Slot Fastener, also sometimes we refer to it as an M6 tab. It's the same as a nut, but it just has the shape that slides into the extrusion here. Okay, and the location of these on the robot are, let's take a view from the top. There are 2 here, there are 2 here, there are 2 here, there are 2 here, and then we have 2 on the right side of the plate here, 2 on the left side of the plate, and then the same on the other wheel of the robot. Those same tabs are found underneath the caster wheels, 2 of them each, or we might also add a third one if we need more. In regards to the 90-degree aluminum brackets, some of these kits came from Amazon with a kit including this style of tab. This does the same job as the black tab. It does the same thing, it just has a different profile. The only consideration that you need to make is that the black tab may not fit in certain locations where this right hand side for me is extending further outwards from the fabric. So the M6 by 10 bolts and the M6 by 14 bolts are the same, except for obviously this one is 14 millimeters long. And once again, we're measuring that dimension from the bottom of the head. Okay, so in the locations where we're passing through a thick plate, then we use the 14 millimeter. We're going to basically be passing into this. And in the locations where we're using one of the thinner pieces of hardware, such as the 90-degree bracket or the caster plate, then we're going to use the shorter M6 by 10. We need to have enough threads exposed in order to pass into the aluminum extrusion like this without crashing into the inner wall. I lied. These screws here are actually 12 millimeters, and the 10 millimeter is like this. So the 10 millimeter can successfully pass through the thinnest plate and into the aluminum extrusion without crashing. And in this case, we're likely to have a lock washer and or a flat washer that gives us just a little bit more clearance to the middle of the. This is the M6 flat washer, and the inner dimension is a little bit larger than 6 millimeters, so that it can do a clear pass-through with a nominal 6 millimeter thread, and the outer dimension I can't remember. Okay. So these flat washers are primarily used on the plates to spread the force of the bolt on the plate. In this case, it's acrylic, and in our newer versions, it's all aluminum. These M3 Phillips screws have a countersunk head, and they belong in the motor. There's 3 screws for each motor, and those screws are going to pass through the plate on these 3 holes, and they're going to be flush with the plate once they're fastened. This is a 6 millimeter hex key, not to be confused with M6, because the 6 millimeter hex key actually fits into the M8 bolt that's in the wheel of the scuttle. And this hex key can go into your ratcheting driver, put it into the right direction, and then start ratcheting. I'll just keep going. The 4 millimeter hex key, it looks like this, and it corresponds to a 4 millimeter Allen wrench. I guess technically both of these are hex keys, but only this one is the Allen wrench, hence my Venn diagram. And then over here you have the 2.5 millimeter hex key and 2.5 millimeter Allen wrench. And in most of our kits, we've painted our wrenches to be a uniform color. So blue is going to be 2.5, green is going to be 4. The 2.5 hex key right now is just used in these set screws. That should be the only location right now on the robot. And then the 4 millimeter hex key is used in all of the M6 hardware. And that should be all. Just in case nobody took the time to actually check, the way that these hex keys are specified is the 4 millimeters would be the dimension where a flat side has a distance to the next flat side. So this is the 4 millimeter hex. I'll explain the location where these set screws belong. Well, Scuttle is undergoing some testing, so there's one alternative type of pulley for the motor, and that's the aluminum one, where we customize it by drilling a hole that meets with the shaft and then tapping it so we can fit the set screw in. I won't thread it in right now. We fit that in there and then keep it from sliding along the shaft. The other version of this pulley is our plastic 3D printed one, where we have the D shape already designed into the part, and then there's potentially no set screw required, because if it's a press fit, we have had some success with the press fit and we didn't need any set screw. But alternatively, we can also drill and tap this one. The question is whether this ABS plastic would be strong enough to hold up. This is the M8 bolt that acts as the axle for our Scuttle. It's going to pass through these bearings, and these bearings will be press fit into these areas in the skateboard wheel. In between the 2 bearings, you're going to have the steel spacer, and then the steel spacer prevents these bearings from getting compressed against each other. And then on this side will be the plate. After the plate, you're going to have a flat washer here, and then the lock washer, and then you'll have this nut.